Hello guys, today we'll talk about an equivalent circuit of a transformer. So an equivalent circuit of a transformer consists of primary circuit and the secondary circuit. So on the primary side of the transformer we have the resistance and the inductance, as well as on the secondary side you have the resistance and the inductance. This is due to the flux leakage of the transformer. So in this case, we won't be representing the core of the transformer. We take it as negligible, since it's 3 to 5% of the full load current in the primary side. So on the transformer itself, we have a ratio. Let's represent the ratio as A. Ratio, because the transformer has primary windings and also has secondary windings. So this is now represented in the form of a ratio, which is N1 over N2. So the ratio affects the voltage and the current, especially also the resistance, especially if you are referring to the primary or to the secondary side. Okay, so all the ratio is also represented by primary voltage and the secondary voltage and secondary current over primary current. So this is the voltage ratio and this is the current ratio, but they all equal due to the windings of the transformer. So now let's say you want to refer secondary current. So secondary current flows here. So it's I2, and primary current flows this side. So it's going to be I1. Sorry, it's going to be I1. So in a case where maybe you are given a question whereby you have to calculate from the load side to the primary side. So if you have a current on the load side, you can refer that current to the primary side and get the current on the primary side. Which formula do you use? So to derive the formula to do that, you can use the ratio combination of V1 over V2. V1 over V2 equals to I2 over I1, right? So this ratio will get you the formula that you have to use to calculate the current when you're referring to the primary side. So if you cross multiply this is going to be V1, I1, I2, V2, right? So how do we now calculate the current referred from the secondary side? So this means this current, you are having this current, but you don't have the current on the primary side. What you want to figure out is to know the current on the primary side. So if we take this current and we take it this side, so from this formula we will substitute I1, because we don't have I1 at this moment, with I2 prime. Let's call it prime because it's not the same as I2, but you want to use the influence of the windings of the ratio of the transformer to determine the primary side current. So this will be equal. So we substitute this in the place of I1. So V1 and I2, sorry, let me just write it uniformly. I2 prime times V1, right, equals to I2 V2, right? So because primary current is relative to secondary current, so we have to use the secondary current to determine the primary current. So we can divide here by V1 on this side as well by V1. Cancel this, cancels that. What we are left with? We are left with I2 prime equals to I2 times V2 over V1. So if you're looking at this and you are looking at our ratio combination, this is in the inverse of our ratio, right? This is the inverse of our V2 over V1 is the inverse of the ratio. So this means our ratio is A equals to V2 over V1 over V2. But now we have now a reciprocal of this. So this will now be, remove that, this will be now 1 over A equals to V2 over V1, right? So in this case now, we have I2 prime equals to I2 multiplied by 1 over A, right? So when we want to calculate, when we want to refer I2 to the primary, this is the formula to use, divided by A. So A2 prime, okay. So this is the formula to use, okay? This is a standard formula. At any given situation, you have to use this formula. You don't change this formula. Okay, so how about when we want a voltage? When we want to refer a voltage from the secondary side to the primary side. Okay, so we will use the same arrangement. V1, let's say I1 V1 equals to, from the ratio of the transformer, equals to I2 over V2. So the same principle works here as well. So if we want to refer now V2, this V2 to the primary side, right? Say, let's say in this case, this V2. So all calculations are done whereby V2 and V1, we're taking it as they are equal when we have two primary when we have primary and secondary as the same windings. So we're just going to use it at that point. Let's take it from there. So if we have now this V2, V1, we want to refer V2. So V2 also will be V2 prime on the primary side will be equal to V1, right? So in this case, we substitute from V1, V2 prime. So it will be I1, V2 prime equals to I2, V2. Then we divide by I1 because we want V2 prime. So V2 prime now will be equals to I2 divided by I1 multiplied by V2. So we can see here again that this here is equal to our ratio A. Is equal to our ratio A. So our V2 prime is equal to A times V2, the opposite of I2 prime. So the ratio multiplication to these quantities is the opposite of each other. So on the case of I2 prime, it's equal to I2 divided by A. In the case of V2 prime, when you're referring to the primary, this will be equal to V2 prime equals to A times a V2. So it's always the same, always the same. So it applies everywhere. So basically, when you want to refer current from the primary to the secondary, you will do this, you will do the opposite. In fact, your formula will be opposite of when you are referring from the secondary to the primary. So I1 prime will be equal to A times I1. Okay, so this is when you're referring to the secondary, right? So voltage as well, if you're referring this voltage from primary, to the secondary, it will be the opposite of when you were referring from the secondary to the primary. So the formula will be V1 prime equals to V1 divided by A. Okay? V1 divided by A. So it's the same calculations, you just substitute here in the place of I2, you substitute I1 prime. If you want to refer V1 to the secondary side, you just substitute from the V2 component, you substitute V1 prime, right? Then you calculate and you will come up with these two formulas. This is to when you're referring to the secondary side of the transformer. Okay.